Hi everyone, and welcome to a new episode of Unmistakable. Before introducing our amazing guest of today, if you are enjoying our content so far, please hit the YouTube subscribe button, visit our website www.uapeducation.com, and follow us on Twitter and Instagram. Today we have the honor and pleasure of interviewing Professor Matthew Szydagis. Dr. Matthew Szydagis is a physics professor at the University of Albany and an experimental astroparticle physicist focused on dark matter and UFO research. He's a member of both UAPx and SCU, and you may have seen him in the film A Tear in the Sky. Dr. Szydagis is the lead author of UAPX's first scientific publication and is a regular expert feature on the History Channel's The Proof is Out There. So, without further ado, let's welcome our guest. Professor Szydagis, thank you very much for joining us at Unmistakable at UAP Education. It's a real honor and pleasure to have you here, and I'm thrilled to talk with you about lots of interesting stuff that I heard you saying in other podcasts, and something that I just realized that you are working on with UAPX and on the personal side. So, thanks. So let's start with your work and expertise at UAPX. Radiation detection is actually your signature, we could say, your personal expertise in the UAP detection process. Could you please expand on this? Why is that so important, and what are you working on in order to achieve this?
So I bring this expertise because my main effort, my non-UAP day job is on dark matter detection. So I'm a particle physicist, and so that's the expertise I can bring. And the reason why it's important is because there are many cases where witnesses or victims, you could call them, have claimed direct physical harm, biological harm that sometimes appears to be consistent with radiation or radiation burns. And that's sort of kind of, in a sense, stronger evidence, more tangible than video evidence, if that makes sense.
Yeah, absolutely. And I also, Professor, according to what Professor Kevin Knuth presented at the Soul Foundation symposium, at UAPX, you are working to power your UFO observing equipment while luring in UFOs thanks to a device I think you invented and you are patenting now, which is a lithium-powered nuclear fission subcritical reactor. So I would really love to expand a little bit on that, if you want, for us to explain what it is, what importance could have actually in UAP detection, and not only because, as far as I saw in the presentation, it is a safe and clean device, and it also has potential advantages and benefits to society. So I think it's a great idea.
Well, I can't give too much detail since the patent is still pending.
Yeah, of course.
At my university, but I'll do the best I can in summarizing what is publicly available and that I'm allowed to say. So the principle basically was inspired because of UAP research, because we had been discussing on UAPX, talking about the famous cases, like Robert Salas' story and Robert Hastings' book, UFOs and nukes. And I was just thinking to myself, hey, wouldn't it be great if we could have our own nuclear reactor, kind of as a joke? But then I realized, wait, maybe we could. And I started looking into things and discovered that you can create nuclear fission in light elements like lithium, not just in heavier elements, and do it with high energy neutrons instead of low energy neutrons. And that's really how the idea was born. So the main advantages are that the technique relies on neutron activation, so the reactor can be turned off, and so that way there's no risk of a dangerous nuclear accident, because until it's made radioactive, lithium and the other elements and isotopes in the reactor are stable until they're tickled by neutrons at the correct resonance energies. And basically, so a runaway reaction should be impossible, and there are no harmful there are no very long-lived isotopes that are created from the reaction. So these are enormous advantages compared to existing technology, and we might also be able to recycle lithium batteries and turn them into fuel for nuclear reactors. And that's important because there's currently no global plan for what are we going to do with all these lithium batteries from all the electric cars, right?
Exactly.
Are we replacing one problem, climate change, with a different environmental problem? But I should stress, yeah, we're not powering anything on any expedition, maybe in 10 years.
Okay,
I
okay.
mean, like this is a long-term vision of
Yeah.
building a completely new technology.
Okay. Wow, that's great. And it's great that you also mentioned that this invention was inspired by your studies around the topic of UAPs, because I think that many public and scientists also sometimes forget that studying something which is unknown, like, for example, UAP, but there's enough circumstantial evidence about it, can also lead to important discovery and breakthroughs, not only UAP related, but as you said, related to environment, related to science in general, and other
Yeah.
very important aspects.
Mm-hmm.
Yeah, and talking about expedition, since you mentioned expedition, you actually made a very well-known expedition near Catalina Island and that actually ended in the documentary A Tear in the Sky.
Yes.
And I think that I read that you are about to release. I mean, you will release a paper on the first results of your studies during the expedition in the next month, if I'm correct. And I guess it refers to this expedition. Do you have any update about it, or?
Yes, that's actually not correct. The paper
Oh,
was released on December 8th, so
oh,
it's of
oh,
this
okay.
year.
I missed that. Oh,
Yeah,
okay. That's
we
great.
tried to let everybody know. We sent dozens of emails, but it didn't catch on. There was, Gary Voorhees, president of UAPX, tweeted about it, but like for
Okay.
some reason nobody was paying attention. But it's only the pre-publication because it still needs to go through peer review.
Yeah.
But the preprint version is publicly available,
Okay.
waiting for people to realize that it exists. I mean, we spent hundreds of dollars on a press release and sent it into all the major news agencies, but there was not very much interest, it seems.
I see. Yeah, that's a common problem in UAP related studies. I think the
Yeah.
stigma is still huge, I guess.
Yeah.
But of course, if you can then share the link, I will be happy, of course, to share it
Sure,
also
I will
for.
I will drop it in the chat for you right now, and then you can save it.
Okay, great. Of course, you mentioned dark matter. Your main subject of study is actually dark matter. So your focus is on dark matter and detection of dark matter. So you said it in one podcast something that I found very interesting, and it is that there's also stigma in the academic, let's say, environment, society towards dark matter, not only UAPs. Why do you think is that?
Well, that's because um, there are a lot of different fields of science, of course, and some are deal with, instead of making, new discoveries of things that aren't there yet, that we don't see it. Some fields of science are based on studying something we already know exists for sure and pulling out its properties. And those who do that kind of science sometimes look down upon those who are trying to look for something that it is not solidly established yet, and they think that they're looking for something that isn't there. You know what I mean? Does that make
Yeah.
so I hope that
Yeah, it
makes
totally makes
sense, that
sense.
there's something, a different types of science, and people who they've got something that's already been discovered, and their new discoveries will be the properties of that thing, versus something that that is not, and things also that are not directly measured in the lab on the surface of the Earth also can be challenging sometimes.
Yeah. Yeah, but that is also true for astronomy and a lot of other disciplines. So
Yes.
they should not exist according to this attitude, you know?
Yeah. No, but the irony is no, it's I've met astronomers who think there's no dark matter. Which is kind of crazy
Yeah.
because that's where the original evidence
Yeah.
comes from, is from astronomy, of course.
Yeah, and there's actually a lot of good observational evidence about dark matter, even if we don't have the, let's say the smoking gun proof, which in scientists is not very common actually.
Hmm.
Okay, so which are these observational evidence, the most important ones, in your opinion?
There are so many. Those who say that there is no dark matter and then we need to modify gravity only pick one. They only pick the piece of evidence from 1979, and that's galactic rotation curves. However, there's so much more. There's gravitational lensing. There's colliding clusters of galaxies like the Bullock cluster. There's the cosmic microwave background radiation. There's Big Bang nucleosynthesis. There's large scale structure. There's baryon acoustic oscillations. The list
Wow.
goes on and on and on. We've discovered galaxies that are almost 100% and almost 0% dark matter, which implies that it is stuff, and you can have more of the stuff and less of the stuff. So there are all these numerous pieces of evidence. Not all of them are completely independent of each other, but enough have enough degrees of independence from each other that they basically all cross-check each other towards the same conclusion.
Okay, wow. So, and have you seen some important recent discovery, or are you foreseeing important discoveries in the years to come about dark matter? Hopefully, something that you are studying.
Yes, the LZ experiment that I work on will hopefully produce an actual direct detection,
Okay.
as opposed to the observational
Yeah.
evidence, so that we have better identified what particle it is, if that's what it is, if it's some sort of new subatomic particle. And so the next couple decades are going to be probably very important.
Okay. And could you explain a little bit how the project works, or is it something that you can't go into?
Sure. So, well, no, it's not. Nobody cares about dark matter. It's not classified,
Yeah.
even though it's funded by the U.S. Department of Energy. So I work on the LZ experiment, which uses a large tank of liquid xenon that's placed underground in South Dakota. And basically, when a particle comes in, it interacts with the xenon and produces both scintillation light and ionization charge. And the ratio of those two tell us about the type of particle that interacted. And so we're looking for a greater number of events than are expected, and looking like dark matter in the right signal channel, basically.
Wow, fascinating, fascinating. Um, and apart from the fact that both dark matter and UAPs have such an overwhelming amount of observational evidence, circumstantial evidence, uh, do, is there any connection? Do you think there could be any connection between the two, or the study of dark matter could actually advantage also the study of UAPs, or vice versa?
Yes, and I've given a few talks on this that you can find on YouTube,
Yeah,
to the SCU, the Scientific Coalition for UAP Studies, of which I'm also a member,
yeah.
just like UAPX. So I've given at least 2 or 3 talks on that exact idea,
Okay.
and it's a very speculative idea, but it's operating under the. I have to be clear that it's operating under the assumption, right? It's only assumption, the hypothesis that at least some tiny fraction of UAP represents some sort of advanced craft, right? Operated by some kind of non-human intelligence, some sort of
Yeah.
intelligence. And in that scenario, I had suggested that dark matter or dark energy, which there's even more, but it's not related to dark matter. That one of these could be some kind of fuel source potentially, if there's enough of
Mm.
it, and there should be plenty within the universe. And the idea is that way if you capitalize on dark matter, which is about 25% of the universe, or dark energy, which is 70%, maybe you don't need to carry fuel with you. And that would be a very significant advantage for interstellar travel. But I don't have like that's a crazy idea. I don't have like, I can't explain to you how you would use dark matter that way, because we think it doesn't interact. So there would be no way to collect it that we know of. There'd be no way to cause a reaction that would produce any energy. So it's very, very speculative. I don't have a direct connection.
Yeah, of course. But it's very interesting that you made this point. I think that this could be really an interesting field of study to find out more about it. I'm also interested, just to shift a little bit, apparently, topic, the relationship between science and science fiction. Let's say that I know you are also a science fiction fan, like many you said in various podcasts. For example, your passion for Star Trek Next Generation, which I'm also totally into. But I realized that many people, so the public and also scientists and public opinion, they usually tend to consider science fiction as the anti-science. They don't really. They also, for example, if somebody experiences a UAP. Have a UAP has a UAP experience or a sighting, or some scientists come out with interesting hypotheses on UAP or any other things, that are considered science fiction. People tend to dismiss them, especially if they are interested in science fiction, if they just saw a movie about UAPs, if they just read a book about, which is pretty frustrating, because I think they are missing that science fiction is actually almost always written by scientists, and also the more important science fiction films are actually have scientists as consultant for the movies, or TV programs, like, for example, you also are a consultant for the History Channel. And so you know probably what I'm talking about. And so people don't realize that science fiction is probably a prediction made by some scientists of how science would look like probably in 10 years, 100 years, a million, like 1,000 years. I don't know if you agree on that in some cases, like a kind of a forecast of what could be science.
That's only partially true. I have to correct you. Most science fiction
I love that.
scientists.
Thanks
So most science fiction writers are just writers. Scientists don't have time to write fiction.
Yeah.
So the vast majority, I mean, there are exceptions like Isaac Asimov,
Yeah, of course.
to a degree, but that's not the case anymore.
Okay.
And so a lot of science fiction is not necessarily meant to be a prediction about the future, but just speculation about like taking, for example, one particular aspect of human nature or human culture and taking it to an extreme. But it's not always, the lines have gotten kind of blurred. So what you're thinking of was true probably 50 to 100 years ago. That's not true anymore, because science fiction has diversified, and it sort of crosses over more with fantasy, and sometimes it's called speculative fiction now, just SF, and not science fiction. Now, personally, I do prefer some of the older science fiction, and sometimes that's known as hard sci-fi, and sometimes, yes, there were stories that were meant to be predictive. But one thing I do agree with you on 100% is science fiction is not anti-science, and it never was. I've never heard of that before. It's always been pro-science, despite the many different forms it's taken over the years. It's never been, it's the complete opposite has been true. And many scientists have been inspired by science fiction authors and television and movies like me.
Yeah, exactly. I think inspiration is also a very important part, because sometimes, even if it's speculative, it can contain a brilliant idea and brilliant understanding of something that is not discovered yet, and maybe will be a discovery in the future. So I think it is an important probably part in this kind of aspect. something else that I really appreciate in a few of your interviews is, for example, your take on the famous quote, "Extraordinary claims needs extraordinary evidence," which I think was absolutely brilliant. For some reason, we always thought that the extraordinary claim is that we are that actually we are not alone, but it's probably the other way around. You know, is how have we come so far thinking that we are the only species in the whole universe? Why that happened to
Oh,
humanity? I
why we
mean,
came that far?
yeah, I mean, in
Um,
this such a vast universe.
well, because we didn't understand the vastness of the universe
Yeah,
for most of human history.
yeah,
Um, until 100 years ago, we didn't even know that the Milky Way. We didn't realize that the Milky Way galaxy is one of many galaxies. That's not the entire universe, and so the vastness of the universe is not culturally broadly well understood, and we
yeah.
don't teach it to our students, at least not at an elementary level.
Yeah, that's actually the next question that I wanted to touch, because you also about education, which I think is the most important thing, and what you say, the elementary level, which is probably where the belief system and the also the you know and also the like I don't know thinking, critical thinking, it's actually modeled, you know. So we still have, I talk about, for example, other other discipline, not of course physics, but we still rely on books and knowledge, which is very old. Actually, I was also relying on the knowledge of science fiction writers, which was very old, like connected to my generation, you know. But for example, I remember you said that in the late 80s, if I'm not wrong, or beginning of 90, you know, we thought that there was only one planet. We actually knew one planet outside our solar system, and now we know a few thousand of them, you know. So that's probably what also caused the different the switch in the you know for us. But do you think that this information is updated at school, in elementary school? Because you said
No,
exactly that it
no, it is
was.
not. It is not. So students are still, we're still arguing about whether Pluto is a planet. Who cares, right? There are thousands of planets well outside our system. No students are taught this in
Mm,
elementary school, high school, or even
yeah,
college, depending on what classes they take and what their major is, and whether they're what general education, you know, or core classes they take. So no, this information is not being percolated. And so if you took your microphone and went down the street, you would probably spend several hours, you know, like the man on the street type, you know, a documentary stuff. You would probably spend several hours before you found someone who knew that there are a lot more than just 8 or 9
yeah,
planets.
absolutely. Yeah, and that's tragic in my opinion, because
It is, yeah.
yeah,
It is, yeah.
for both public opinion, because of course public opinion has a weight, you know, in society, and of course if everybody's convinced that we are alone, that there's just one planet, or so it's a very limited view or understanding of the reality. But on a scientific level, I think that it's really a tragedy, because what happens to these students when they, for example, come to a university and they have such you know, bias on they think to know a lot of things, but and probably they discover, if they luckily find a teacher like you or a Professor Knuth, you know, they found a new world that maybe they are not going to accept at first. What's your experience, for example, as a teacher? I know you are a full-time teacher, so
Hmm?
what's your
Well,
experience with the new generation of students, and the problem they encounter because of this?
my experience is very negative. They get worse every year.
Okay, yeah,
And some of that's not their fault. It's the high schools and the elementary schools are failing.
yeah, yeah. We always say that education is the most important thing, but we totally underestimate that it really is.
Yeah, but we don't give it enough money
Yeah,
in this
exactly.
country, at least. So like, yeah, we claim it's so important, but then we
Yeah,
don't provide enough money to
Yeah.
educators and for education, especially, you know, at the level younger than mine, of course, the
Yeah.
elementary and high school level.
Yeah, of course. It's the same in Europe, I can assure you. Probably, maybe it's a little bit different in Northern Europe, but in the rest of Europe, also education is not really well these days. Okay, so for example, one other interesting aspect for me is everybody talks about artificial intelligence nowadays, for example.
Mm-hmm.
Also here I have a similar question than the one I did before. Do you think there could be a connection between artificial intelligence and UAPs, for example? So what we see could, of course, be artificial intelligence, for example, or will artificial intelligence help us and help you as scientists to discover more about UAPs and to find their real nature?
Yes, I think so, um, but I think there was two separate questions there, because is there a
Yeah,
connection?
yeah,
Maybe you meant, are
yeah,
UAPs maybe
yeah,
artificially
exactly.
intelligently
That's the first
controlled?
question. Yeah,
Yeah, that's entirely possible. We do that, right? We send robots to Mars and the moon because interstellar
hmm,
travel is so hard, interplanetary even within one system, intra solar system travel or intraplanetary. So um, it is entirely possible that um, AI probes exist. I mean, this is something that Avi Loeb has pointed out repeatedly.
yeah,
But there's another possibility, which is that our language does not have the right words for this. Maybe that civilizations that are thousands, millions, or billions of years more advanced, they don't. There's no more borderline. They've merged with their machines, and there's no border between natural and artificial intelligence. It's just some sort of continuum or spectrum, and you know, everything and everyone's a cyborg of some kind. This is a possibility that we also can't discount.
yeah. That's also very, very interesting. And I think we as human, we tend to see the two things as separate. Of
Mm-hmm.
course, it's natural for us. There's biology and there's technology, and even if we think of, for example, an advanced species, we can imagine that they actually blend them together. But somehow, from a philosophical point of view, for example, I'm wondering if the state of like biological and technology blended together is probably the origin of it. I don't know if I'm making myself clear. Uh, I mean, it could be like as a whole, and maybe we are just living like a part of it.
Mm-hmm.
I don't know if that makes any sense or,
I think so, but yeah, I think we just don't know.
yeah, and we will probably never know. I think. I'm
Well,
afraid.
no, I'm more optimistic than
Okay,
that.
okay.
Yeah.
So do you think we will know something more, much more in our life, or it will be in the next centuries?
I'm optimistic that within my lifetime. But the thing is, I plan to live to 117.
That's great.
I'm optimistic that within my lifetime we'll understand the nature of UAP. Is it some sort of non-human intelligence? Is it a natural phenomenon? Is it a combination of multiple phenomena that are
Yeah,
being conflated? I think that we will make some more progress.
yeah, I hope so too, and I actually think so too. I need to ask question, but I'm also optimistic.
Mhm.
Yeah, I'm also interesting. I think UAPX, for example, is one of the most advanced. You rely on a complex sensor system to detect UAPs, which I think is, of course, it's very clever idea because we need to have all data, the most data from all point of view. And I know that you have already said that in other interviews, but for our viewers that may not know, what sensor are you specifically using at UAPX or?
So the idea is to have a combination of
Yeah,
visual sensors that operate on different wavelengths. So you have infrared, you've got visible light, and we're going to add, if time and money permit, of course, we want to add
yeah,
ultraviolet detection capability as well. And then there's the ionizing radiation that we already talked about
yeah,
earlier. we want to add also electric and magnetic field detection, as well as sound detection, just the different ways, all the different ways that are possible, for reasonable cost, to have a diversity of different sensors that just give us information about anything, right? About anything that can be happening externally.
Okay. Okay. And I also, since I'm a musician and a sound designer, I'm also interested in the sound aspect of it. And I know that you also plan, or if you're not using them already, to employ sound
Yes,
detection.
but it's very challenging because we live in a very noisy world.
Yeah.
Of course, there's no such thing as perfect quiet. Even you have a dark sky and you're looking for UFOs or something. There's going to be noise from the insects, the crickets. So that is a very challenging problem. But the visual problem is also challenging because you've got airplanes and birds and drones and helicopters to worry about. So it's not an impossible challenge, but it's still a challenge to deal with all of the background noise, literally, that you have. But we want to implement as many different kinds of sensors as we can.
Yeah. And if I may ask another question about this, because most UFOs, most UAPs are reported to have no sound, basically. And I
Yes.
was always thrilled about this because I always wonder if this is a byproduct of their propulsion. I mean, if we are of course seeing advanced craft, if that's the case, or are they cloaking sound intentionally? For example,
Mm-hmm.
what's your take on these?
Well, my take is that an unusual absence of sound, such as a drop in normal sound background, as some people report, like
Yeah,
unusual quiet, that's measurable. So that is a testable hypothesis. So lack of sound is a sound, if that
yeah,
makes sense, because
absolutely.
there's always background noise of your environment that you can characterize, and if that suddenly disappears, that could end up being a statistically significant measurement in itself. But also, you're thinking of how humans hear sound,
Yeah,
and
yeah,
we would be looking at both infrasound and ultrasound as well, outside of the human range on both ends, because who knows, different technology, if we're dealing with advanced technology, may have side effects that produce sound, but not the way we define sound, to produce pressure waves, but outside of human hearing. Just like how I mentioned earlier, there are colors that are outside of human visual perception, like ultraviolet and infrared. And so this is mentioned in our paper, which I don't know if you saw, but half hour ago I did drop the link into the chat as I
oh
promised.
yeah, yeah, I saw it and I will share it, so thanks a lot for doing it.
Very good. Yeah.
I'm really eager to read it, since I actually missed it, because I think I read this, I heard this in an interview by Professor Knuth, which was actually released a few months after, probably December. I mean, the Soul Symposium, so that's probably why I thought it was still happening.
Yes. So
Okay.
the Soul Symposium was many months ago.
Yeah,
It
yeah,
was
I
last
know.
fall. And so his talk was accurate because at the time it didn't
Exactly.
exist yet. Yeah, exactly.
Exactly.
Yeah, so he was saying in his talk, he said coming in a few weeks. Well, those few weeks were,
Okay, yeah,
a few
that's
months ago. Yeah.
that's great to know. So I will post it and I will make some also related posts about this. And okay, I would like to ask you one more thing. How were you? I probably partially know the answer because I already heard it in another podcast. But since we the name of our podcast is Unmistakable, we were inspired actually by lots of pilots encounters and reports where they actually say, or they know what they saw. There was what
Mm-hmm.
they saw were really unmistakable for them. So but unmistakable could also be a scientific discovery, an observational data, or a book that you read, or an intuition. So what was for you the key moment in that made you switch from maybe not believing the reality of the phenomenon, and to understand that, yeah, there is something behind it,
Well,
if you did?
those are two separate. So I had one answer in
Okay.
my mind already. But then towards the end, you kind of change the question because there's two stages. So my entire life since childhood, I was pretty sure there was something real there. I mean, I grew up watching Unsolved Mysteries with Robert Stack, and he'd cover, like Rendlesham Forest and the Belgian UFO wave of the
Yeah.
1990s and all these famous cases on the same show that also covered, like true crime,
Yeah.
and human murderers and things like that. And so to me, that already was like implied that this was real. But
Mhm.
a separate question is that is it worth pursuing though? And is it worth taking the risk,
Oh, okay.
financially and career wise? And that the moment that for me is the same moment it was for many, many people. So probably everyone gives you the same answer. And that's the publication in
Yeah.
December of 2017 of the New York Times article and Lou Elizondo coming out
Yeah.
on TV.
Yeah, I agree. And why do you think, for example, people not because I don't know how is it the perception of this phenomenon in the US, for example, in Europe, I guess most of the population is not aware of for example, this very famous New York Times article. So it was
Mm-hmm.
not such an ontological shock here. And even if they come across it, they probably don't have the instruments to understand it or live there. So it's just an article, and probably here nobody believes in newspapers and TV anymore. So, what do
Mm-hmm.
you think is actually the reality in the United States? Is more or less the same? The majority of the population is not really aware, or did it really have a big impact on the average people?
It had a bigger impact than what you describe in Europe, but only on a few people. I've still encountered people who have no idea what I'm talking about. I mentioned the article. They say, "What article?" And people don't even know there was this famous article in the New York Times,
Yeah, I
2017.
know.
So it made an impact only on people who were already paying attention. So it did not make much. I don't think it made it. It seems like it made a major impact, but maybe not as much as it should have, because
Yeah,
again, people don't get their news from newspapers anymore. They just go on YouTube or TikTok or something, and we don't have central
yeah.
um, news gathering anymore like we've had for for decades or
Yeah.
centuries.
Yeah, and one of the most interesting thing that I'm seeing is that there are many journalists actually in the in the UAP search for in the UAP transparency battle, that they
Yeah.
actually have those great qualities of the old journalists, all the old investigative journalists that are really putting their career at risk. They really
Mhm.
want to discover something, which I think is pretty unusual considering the rest of the information we see. So that's also what tells me that there's really something very important beyond that. So
Mhm.
it's a real topic that needs all of the attention. Okay,
Yeah.
so what are just to conclude our interview? What are your next projects? And if you can already tell us something, what's your next step in your career, in your studies, and
Oh, we don't know because we need money first. So we can't do any more
yeah,
expeditions. We can't do any more
okay.
studies until we get funding. So really, the next step that's going to happen is we're just waiting for external peer review by other scientists, by probably by skeptical
Yeah.
scientists of our paper, and hopefully getting our paper through peer review. If that happens successfully, then we'll
Yeah.
be able to write several more publications for from what we learned in the original expedition. So we can still make a lot of progress for a while without another expedition. We can
Yeah.
continue to pull more conclusions and information out of the week of data we have from our first expedition because it was so despite many flaws, it was still rich enough that we're able to pull out maybe multiple ideas for new instruments and new calibrations, things like that. So even without funding, we have a few things to keep us busy, but ultimately we're going to need we're going to want to mount expeditions to more, supposed UAP hotspots to be able to gather more data and better data.
Yeah, I think it was incredible what you did for and I just saw partially in a tear in the sky. Honestly, when I heard that you were going to a hotspot in just 4 days, I think, or 4 or 5 days, if I'm correct, I thought, okay, that's kind of the recipe for failure, But you were able to monitor, like, to detect lots of stuff that then course, we don't know what they you will have to study it. You will probably already publish important information in a paper that you just sent me, I think.
Yes.
Yeah, but it was incredible, and I think that's how science needs to work. So, thank you very much for your time. You were very generous, and it was really an inspiring conversation. And we hope also that our viewers will go to check the publication and also your website. And is there, of course, a way to support UAPX? If there is a way, I will put it in the link so that people can go and visit the website.
Yes, I will put a link to our website in the chat here so you can save it. So yeah, people can go and donate to UAPX. So UAPX is a 501c3 federal nonprofit organization, and so proceeds go, and nobody has a salary, everyone's a volunteer.
Yeah.
And so money does not go into anyone's pockets. It goes into equipment, it goes into supplies, and hopefully someday into travel expenses as well. So I've dropped the link in your chat so you can share that.
So thank you very much again, and I wish you best of luck with UAPX and your career and any of your projects.
All right, thank you so much for having me.
Thank you very much.